Hello, I'm Bernard Lee. I'm with Logos Biosystems. Today, we are going to have an in-depth look into the software functionality and how easy it is to set up an imaging experiment and subsequent data analysis. Celena X comes with two major softwares. One is Celena X Explorer that lets you design from a simple to a complex multidimensional time-lapse imaging acquisition. The second component of the software is called Celena X Cell Analyzer that gives you ability to design a customized automatic image analysis and processing pipeline for an automated data output. Unlike any other software, what you may notice is a lack or absence of a top menu bar. Everything you need is laid out in a very easy to understand graphical interface. In the software, all components such as lens selections, light channel, and related exposure and illumination settings are easily accessible by a click of a button. There is also a control to manually adjust focus up and down. You can make use of image-based autofocus to find the best focal plane. Quickly found the best focal plane. One of the biggest strengths of the Celena X software is the use of a graphical vessel template. There are templates available for every possible vessel types, from slide to different multi-well plates. They are listed by product number and by manufacturer. Let's start designing an actual experiment. In this sample acquisition, I'm going to design an acquisition with the two fluorescent channels and one bright field channel with an extensive scan area on a 1x3 slide. We are going to use the 40x dry lens for our scan. The first thing we need to do is we need to proceed to set an exposure time for each channel. As you can see, the channel settings, including a specific light illumination setting, as well as exposure time, can be determined and set into the experiment. Let's start with the bright field. I'm going to make the exposure a little bit brighter, or maybe dimmer. And then I'm going to add that to experiment. So on the right hand side, the bright field channel has been now entered in. The next channel that I'm going to do is GFP. And now I'm going to add this channel, but before I do that, I'm going to manually adjust the focal plane. I'm going to add that to our experiment panel. Great. Now we're going to add Sci5 channel. Maybe I will make it a little bit more intense and then add the channel to it. As I mentioned, the Celena X comes with both image-based autofocus and laser-based autofocus. For our purpose, we are now going to show how we can set the laser-based autofocus. What we're going to do is we're first going to switch back to the bright field and then test out the laser-based autofocus. And we're going to do this for every single field in the image scan area. And let's test out the scan. Yep, the focus is pretty well defined. So now we set the laser autofocus as our autofocus strategy. The next thing we need to do is we need to define the scan area. You can see the current position on the slide is marked with a little light blue color. I'm going to set an arbitrary range and maybe add a few more. Yep, right there. Okay, so we set about 4 by 8 field of view, and then why don't we go ahead, might as well add a G-stack. Of course, we can do simple two-dimensional scan with the multi-channel, but just for our purpose of demonstrating that we can do G-stack, I'm going to actually add a 5 micrometer above and 5 micrometer below from the current range, and then set 3 steps in between or 4 steps in between, and the software automatically calculates that it's going to do 2.5 micrometer step size between each focal plane. And of course, we like to add maybe a multiple intervals just to demonstrate that we can do time-lapse imaging. Let's do 3, and then do as the intervals are repeated as fast as possible. We're going to add that to our strategy. Oh, we need to select the vessel and then add the G-stack, add the time-lapse to our experiment. Now, in the experimental channel, we're going to set bright field as our autofocus reference channel. And finally, and most importantly, we need to assign a file name for this experiment. So let's do this. I'm going to save it to the drive and call it test 1. Save. Now, to start the acquisition process, we simply click Run. The software is in total control until it completes the entire acquisition experiment. Once the acquisition process is all complete, you can review your images from a field to a field and between time points as well as G-focal planes. Thank you for your attention. For more information, please visit logosbio.com. Thank you.